in the sequence number. And what else? Nothing is new. So, what is the AGO today? Again, brief revision, and today's topic is Rutherford's atomic model. What is the topic today? Rutherford's atomic model. Alright? So, how will we start? As usual with the revision, chapter number 3. I think most of you must be remembering the different topics, the name also of different topics, and a few things related to the topics that is a data atomic theory, then modern atomic theory, then the fundamental particles are there, and after that radioactivity, research experiment in which electrons and protons were discovered. They have studied their properties, and then there can what the radioactivity. What is radioactivity? The spontaneous emission of radiations from certain elements due to the disintegration. What does it mean? I told you so many times. It means there exist certain atoms of heavy elements in which the nucleus is unstable due to unequal number of protons and neutrons. So, such nucleus stabilize themselves by releasing some sort of energy in the form of rays. Such elements are called radioactive rays. Okay? Radioactive rays. And we know that these radioactive rays were discovered by Professor Henry Becquerel. He got the Nobel Prize on it. And then the two chemists, Marie Curie and Marie Curie, they worked on a mineral called pitch blende and isolated radium from it. So the Marie Curie got a Nobel Prize on her work in physics, and she got another one in chemistry. Told you that radioactive rays can pass through each and everything, whether it is metal, non-metal, solid, liquid, living, non-living, except one thing. What is that thing? Lead. I repeat, radioactive rays cannot pass through lead. L-E-A-D. It's not lead. Lead. Its symbol is Eb. Its atomic number is 82. It's okay. So, such rays, when are allowed to pass through an electric field. What do we mean by electric field? Suppose the rays are coming like this. Then here they have put a plus plate, positive plate, and here they put a negative plate, as you can see in the screen, on the screen. When they apply this electric field, they have seen that this single ray is divided into, split into three different kinds of rays, alpha, beta, and gamma. Alright? Alpha rays are positively charged, beta rays are negatively charged, gamma rays are neutral. They don't carry any charge. Beta rays are made up of electrons, alpha rays are they contain positively charged particles, helium, nuclear, you can say. Gamma rays, there isn't any material in it. These are just the rays, like sun rays. Among these three, the heaviest is the alpha rays. That is why they are the slowest. I repeat, among these three rays, which are the heaviest? Alpha rays. They are the heaviest. So that is why their speed is very, very less. Around 1/10 the speed of light. Okay? What is the speed of light? 3 lakhs kilometers per second. Means this second passes and light travels 3 lakhs kilometers, 0.3 million kilometers. With this enormous speed, light travels. And what is it? Its 1/10 value? Around 30,000. So this is the speed of alpha rays. Beta rays, since they are lighter, they they move with a speed nearly equal to the speed of light. And gamma rays they move with the speed of light. Okay? Penetration power is very less if we talk about alpha rays, because their speed is less, they are heavy, and the penetration power of gamma rays is very, very high. It can pass through everything. It can be only be stopped. It can only stop through 1 to 2 meter concrete. Okay? Whereas alpha rays, they have very less penetration power, would be stopped just by a tissue paper. Alpha rays can be used in smoke detectors, cancer therapy. Gamma rays can be used in surgery, etc. So these rays both have positive and negative values, advantages and disadvantages. Chemotherapy is done with the help of these rays. Okay, now let's begin today's topic. Wait for a minute. Now we have got some information. Let's suppose we are there 100 years back. Scientists of that era, they have the information then that atom can be split into electrons and protons. Neutron was discovered by Gray in 1932. So we just speak the neutron. We will not talk about neutrons. Only we focus on electrons and protons. So scientists have discovered that electrons and protons are there in an atom. But since the size of single atom is very, very small, no one till today is able to see a single electron. A single electron. I mean that no one is able to see that electrons are revolving around the nucleus and nucleus is there. No? So from where all of these knowledge is coming? It is just coming just with the help of experiments. The things that we can't see can be seen with the help of machines. Like we can't see where the broken bone is, but X-ray can do this. All right. So different theories were put forward to define the structure, to define the position of electron and proton in an atom. Okay? So different models were put. In one of the models, as you can see on the screen, there could be cubical atom. It is none of our business. It is not included in our syllabus. It is just for an info. Well, significant model was put forward by Sir J. Thomson, the same one who discovered electron. Remember, he put forward a model. He thought that the whole atom is 100% solid. 100% solid. And electrons are embedded on it. What does it mean? Suppose if this is an atom, then the whole atom is solid. The whole atom is solid, and this whole atom is positively charged. I repeat, what was the knowledge of at that time? The scientists knew that an atom has positively charged particles and negatively charged particles. Now the question is where they are located. So J. Thomson put forward a model which is known as plum pudding model. Plum pudding model. Plum, you know what we mean by plum. Okay? So according to Mr. J. Thomson, the whole atom will look like a solid sphere. And this whole atom is positively charged. The whole atom is positively charged. And electrons are fixed. Electrons are emitted on it like this. Okay? So there is a balancement of negative charge electrons and the positive charge protons. Or we can say simply in real language that there are as many as electrons as there are needed to balance the positive charge. In short, the positive and negative charge are balanced. I repeat, what was the concept put forward by Sir J. Thomson in his plum pudding model? If you search the net, it is you can find its picture as you can see over here. That the plums are emitted like on cake. In the same way, the whole atom is positively charged and electrons are emitted on it. Okay? Now to test this concept, a scientist, Rutherford, came forward. Okay? A scientist came forward, Rutherford. He performed an experiment and here is Mr. Rutherford. What he did, let's look at the board. Let's look at the board. You know X-rays? X-rays are sensitive to light. Okay? And light means radiations. So he used gamma radiations. Rutherford used gamma radiation. From these gamma radiations are coming from a radioactive element. Okay? So from a radioactive element, he insisted gamma rays to go through. So suppose these are the gamma rays which are coming. These are gamma rays. And here he put a circular X-ray. A circular X-ray. So you can see the gamma rays are striking over here. Can show that globe over here. Can show the images over here. Simple. I repeat, what is the setup right now? Gamma rays are coming from a radioactive substance, and these rays can be viewed on a X-ray by observing impressions, by observing its images. Alright? Then he performed the same experiment by using alpha rays. Alpha rays. Can you tell me what is the difference between alpha rays and gamma rays? Just told you right now. Gamma rays are non-material particles, like sun rays. Okay? And alpha rays are material particles, like I can blow this paper. Why this paper is moving? Because my blue contains particles, material, matter, carbon dioxide, nitrogen gas. That is why it is moving. Whereas under the sun it won't move. Because sunlight is non-material particle unable to move this. Whereas moving. So when you use gamma rays, nothing happens. Alright, but alpha rays, when we perform an experiment by using alpha rays, alpha rays also show images over here on the X-ray. Alright? On the X-ray it shows. Now, alpha rays are supposed like these small balls. Alpha waves are like these small balls. But they are coming one after the other. They are reaching here, reading over here, over the screen. Producing images, fine, everything is fine. Now, here comes the key point. What he did, he put a very thin gold foil, gold paper in their path. What he did, he took a 0.004 centimeter thick gold foil, very, very thin gold foil, and put in the path of alpha rays. What was he thinking? That this gold foil is made up of atoms, and according to J.J. Thomson, atoms are solid. So when these alpha rays hit these atoms, they should go back like this. Okay? This is gold foil, and these are its atoms. So according to the concept of Rutherford, that what was he thinking, that if Rutherford if J.J. Thomson is right, then these alpha particles will hit and will go back. Because, okay? So what he did, he put a gold foil over here. Okay? So I'm putting a gold foil over here. What was Rutherford expecting? The alpha rays should bounce back. After starting with this. But he was astonished to see that most of the alpha particles passed through the foil unreflected, as there are spaces among the gold foil. Okay? So what is the first observation? Most of the alpha particles pass through the foil undeflected. Second one, what else he observed? Some of the alpha particles bend at large angle. They bend. Why? We'll see. And a few alpha particles bounce back. They go and they come back. What are the three observations? What are the three observations? The three observations are: number one, most of the alpha particles pass through the foil undeflected. Second, some bend at large angle. Third observation, they bounce back. Very few bounce back. Now, from these three observations, what he has concluded? Tell me, if I throw this marker in this room, let's suppose this room is an atom. This room is an atom. The room is occupying space, but most of the space is empty. So, what is the first conclusion that Mr. Rutherford got? That though atom is there, but it is hollow from inside. Atom is there, but it is hollow from inside. Like marker can pass through this atmosphere because the whole room is empty except few chairs. I repeat, what is the first observation, Mr. Rutherford? That most of the alpha particles pass through. It means atoms are hollow from inside. That is why these alpha particles pass through, as you will see. Second observation, bending. Alpha rays are positively charged, and you know positive always push away another positive. So it means they are going away, means there is something positive over here. Okay, there is something positive over here. So what is the second point over here? What is the bending of this alpha particle showing? That there is something positive line in an atom. Now we combine first and second point. Most of the space is hollow, is empty, and there is something solid, there is something positive lying in an atom. He, Rutherford, assumed that that thing is present in the center. And he named it that thing, that positive thing, as nucleus. As nucleus. So, enlarging this, suppose this is an atom. So most of the space is empty, so most of the alpha particles pass through. Most of the alpha particles pass through. Most of the alpha particles pass through. It means most of the space occupied by an atom is empty. Second, alphas are coming and they are bending. Why? Because in their path, their ions are positive. That is why they deflect them. So what is the second point? The deflection shows that there is something positive in the center of the nucleus. He named it as nucleus. So first time he coined the term nucleus in an atom. And a few bounce back, these are those alpha particles which hit directly that nucleus. Which alpha particles are returning back? Which are hitting the nucleus directly. Where the electrons are? Electrons are revolving around the nucleus. Alright? So see, since it's the first time that you are studying this, you will feel difficulty. So it is better to see. You can see this in the screen. A beam of alpha particles. Gold foil is there. See, alright? A sensitive plate like X-ray or zinc coated screen is there. Now see this one.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus.
So you have seen most of the alpha particles are passing through. A few are bending at large angle, showing they are deflected by the positive nucleus, and a few, very few, are bouncing back, meaning they are being hit by the nucleus itself. So this is the first. What are three observations? So if when the topic is there to explain Rutherford atomic model, you will write the experiment arrangement, then the observations. These three main headings are there: experiment, observation, and conclusion. Without showing and the diagram also. Without showing these three or four things, your topic will be incomplete. Observation: most of the alpha particles passed through the foil and deflected. First observation. Second, some of the particles were deflected fairly large angle. Out of 8,000, one deflected. A few of them bounced back, and like this, as you can see, most of the alpha particles passed through, a few bent, and very less bounce back. So what is the conclusion? Most of the space occupied by an atom is empty. Deflection indicates something positive lying in the center because alpha rays are being positively charged, are deflected by the nucleus. And in the center, in the nucleus, protons are lying, and atom is electrically neutral, means electrons and protons are equal in numbers, and electrons revolve around the nucleus. Alright, that's all for today. Thank you so much. Take care.